There we go.
All right, how's that look?
Hang on a second.
You can see it. I can see how it looks. That's great. All right, well,
We can see you, we can hear you, we're all set to go.
great. Thank you so much. And thanks for everyone for showing up today. As I was explaining earlier, a couple of hours ago, I was helping to coordinate the International Dark Sky Association's annual meeting, and there were 450 people in attendance out of 2,300 that had registered in 90 different countries. So that was a hoot. So we're gonna focus in on Pluto and its amazing story. So you're gonna walk away from this talk knowing so much about Pluto. I guarantee it. All right. So I think one of the things that's truly remarkable about our solar system, and here are all the major bodies shown to scale. Here's the sun over on the left-hand edge shown to scale its limb, is that we get such a variety of planets out of the condensation of one interstellar cloud. Still amazes me. And the differences of the major planets and the gas giants and the terrestrials, but even on the smaller scale, there's a huge variety of different kinds of objects. These are some of the major moons, if you will. Pluto is shown there in the bottom row near the end, and just to give you a sort of comparison here. And Titan is big. Titan and Ganymede are both bigger than Mercury. If they were circling the sun, we might be calling them planets. So in the long ago, let's see, I think it was in the early 1800s, Johann Bode and Johann Titius collaborated on what became known as the Titius-Bode law, Bode, because he was German. And it's a simple numerical expression that you can see up there at upper right, that does a remarkably good job of predicting the locations of the planets in astronomical units, an astronomical unit being the average distance of Earth from the sun. So, for example, you add 4 to 0, divide by 10, that's 4/10 of an AU. That is almost exactly the distance from Mercury to the sun on average anyway. 4 plus 3 is 7, divided by 10, 7/10 of an AU, 1 AU, and so forth. And this progression did a remarkable job, except that it predicted that there was something missing between Mars and Jupiter. The progression should have predicted at 1.6 AU. I'm sorry, let me do this again, at 2.8 AU, a planet that apparently wasn't there. And so about the beginning of the 1800s, a bunch of European astronomers, and that was the nexus of astronomy at that point in time, the US hadn't really emerged yet, got together and decided they were going to find this planet that was between Mars and Jupiter. And literally, I am not making this up, they called themselves the Celestial Police. And these are the two guys, Baron von Zach was the leader, and Giuseppe Piazzi on New Year's Day in 1801 discovered an object that turned out to be between Jupiter and Saturn, the one we now know as Ceres. And so the problem was solved. We had found the planet between Mars and Jupiter. And in very short order, within the next 2 or 3 years, 3 more objects between Mars and Jupiter were discovered. And they turn out to be the 4 largest asteroids: Vesta, Juno, Ceres, and Pallas. And if you look at tables of old astronomy books of that era, you see them listed as planets in the listing of the sun's planets. And there's a cautionary tale here for what eventually happens to Pluto. So we have now seen a couple of those asteroids at close range. This is Ceres as seen by the Dawn spacecraft. Oh, there we go. Okay. And here is Vesta. And along with Vesta, I include, this is a neat graphic by Emily Lakdawala of other asteroids that we have visited at close range in their size relative to Vesta. So we have a pretty good idea, beginning to have a good idea of what asteroids are like. And so that sets the stage for Pluto, the little planet with a big moon. This is actually one of a series of postcards by an artist named Paul McGehee, who I spent a lot of time trying to track down and never did. Anyway, this Pluto story actually begins long before Pluto itself was discovered. It was no less than John Herschel who imagined that beyond Neptune there was a planet, and that got a little more well formed as a thought in the early 1900s, when both Percival Lowell and William Pickering predicted the existence of a planet X out beyond Neptune, and their reasoning was that Neptune was predicted to exist because of its perturbations on the orbit of Uranus, and after Neptune's discovery in 1846, there was still some thought that Uranus had a residual in its motion that wasn't explained by Neptune, and that's where this notion of planet X, yet another planet out beyond Neptune, came to pass. Well, Pluto was discovered. Lowell, had by 1909, Lowell had built his Lowell Observatory out in Flagstaff for observing Mars. He died in, I think it was 1915 or in the teens, and was never able to really see the fruit of his prediction come true by Clyde Tombaugh. Now, Clyde was a remarkable young man who was born and raised in the Midwest, and was a keen observer with his home-built telescope, made in part from tractor parts on the farm that he and his family occupied. And he did careful sketches of the planets, which he sent to Lowell Observatory, and it impressed them of how meticulous he was. And they hired him. They hired him to run this telescope, which was a new astrograph designed for finding Pluto. And it was remarkable for its day, but way back here at the left-hand end, that is where the photographic plates were held. They were these huge glass plates. And so Tombaugh's job was literally to spend all night in this often unheated dome. It was unheated, but in a Flagstaff winter, it got pretty cold. And then during the day, he would expose the plates, develop the plates and check them to see if Pluto was on it. And the technique was that he would take two images of the same area of sky about 3 days apart, 2 to 3 days apart, and then set them up side by side in this gizmo, which is called a blink comparator, where by looking at the eyepiece right here, he could quickly flip back and forth between the two and look for things that moved. And so, ladies and gentlemen, this is the discovery image for Pluto, one of the two discovery images. And I'm challenging you all to figure out which one is Pluto. It is not this. This is Delta Geminorum. Time's up. All right, Pluto is right here. And remarkably, this was very close to the area that Lowell had predicted that Pluto would be found. But as it turns out, as we now know, first of all, there were no residuals in the orbit of Uranus. It was just uncertainty in the data. And the second thing is that Pluto in no way could have influenced the orbital motion of Uranus. And so it was therefore just darn fool luck that Tombaugh discovered Pluto close to where Lowell had predicted it to exist. Now, this is Clyde in his later years. He was a longtime professor at the University of New Mexico in Las Cruces, which is where he and his wife Patsy lived. This is that same telescope that you saw when he was a youth. Photo I took of him. I got to know Clyde decently well. He was a really great guy. and he had more puns than Fritz does. And so at one point he came back to the East Coast on a tour with David Levy and his wife Patsy, giving lectures and raising money for a fellowship, a graduate student fellowship in his honor. And he showed up in the Boston area, and he and the Tombaugh and Levy, and they didn't really have a place to stay. So we put them up at our house in Chelmsford, and we sold that house some time ago. But the last thing I did before leaving the house was put up this plaque in the guest bedroom. You notice it doesn't say whether Pluto is a planet or not, simply that Clyde had discovered it and that he'd slept there. So, we really didn't know a lot about Pluto. We knew its orbit. And eventually, fast forward a quarter of a century after its discovery, photometry, careful measurement of the light reflected off of Pluto, showed that it had a rotation period of about 6 days. This is a couple of different periods, and you can see the scale down there at the bottom. I'm having trouble juggling all of this. Your lovely faces. Maybe I can do that. Oh, maybe I can. Can you still see my face? Yes, no, yes, okay.
Yes, we can, Kelly.
Okay, good. I've actually eliminated all the rest of you, so all I'm seeing now is my screen. And so you can see that, interestingly, over time, although the period of Pluto's orbit, 6.4 days of its rotation, didn't change, the character of its bright and dark markings definitely changed over that period of time. We'll come back to that in a second. But we didn't know really anything about its surface, about what was giving rise to that rotational variation. And all we knew was that Pluto at best was a 14th magnitude dot. And there's a couple of ways you can get a 14th magnitude dot reflecting sunlight. It could be very small, but very reflective, or it can be much larger and having a dark surface. And both of these, all three of these cases here, reflect the same amount of sunlight in aggregate back to the sun. We couldn't resolve Pluto's surface, so we didn't know which of these was true. Remember, we were still looking for something, at least initially, that could have been enough to, to alter the orbit of Uranus. Well, in 1965, we discovered that Pluto had an orbital resonance with Neptune. That is, its orbit was quite elongated, quite elliptical, such that when Pluto is closest to the sun, it's actually closer than Neptune is. And in fact, that period was from 1979 to 1999. Pluto was its closest to the sun in 89, and it won't be that close to the sun again for another 250 years, give or take. And so the question was, why don't Pluto and Neptune collide? And the answer is that they are in a resonance, an orbital resonance. So technically, it's called a mean motion resonance. Pluto goes around the sun twice in the time it takes Neptune to go around 3 times. And so this close relationship prevents Pluto and Neptune from ever being in the same point in space at the same time, so they'll never collide. But we still didn't know anything about Pluto's size to speak of. And then something really important happened in 1976, and that was Dale Cruikshank and others discovered the presence of methane ice. Well, actually, it was methane in the atmosphere of Pluto, or what turned out to be the atmosphere. But methane, when it freezes, and it should be frozen at that distance from the sun, creates a white ice. So that meant that Pluto was really more like this than this. And it meant that Pluto couldn't be very large and it couldn't be very massive either. And so here's this is a typical spectrum. You know, methane is a very spectroscopically easy to detect gas. And so those broad bands that you see there, this is in the near infrared part of the spectrum, just out of the visual spectrum, were telling us that Pluto had an icy surface. And then something, so we knew that it had an icy surface, but maybe it's an ice covered, giant hunk of iron, a cannonball with a frosty coating. But then something happened in 1978, just 2 years later. It was discovered that Pluto had a satellite. And this is the actual discovery photograph over here, taken by James Christie. And this is the corresponding orbit of what came to be called Charon around Pluto. Now, Pluto is the god of the underworld, and Charon is the captain of the boat driver that carries people down the river Styx into the underworld. And so there's James Christie and his wife Charlene, just gotten married when this satellite was discovered. It says my internet connection is unstable. If it gets bad, somebody let me know, please. But in any case, trying to impress his new wife, I guess, Christie said that he was going to name the new moon of Pluto after his wife, Charlene. But then he realized that it had to satisfy mythology, and he went running to his mythology book, and he discovered that there was this god, Charon, who was one of the gods of the underworld, and was the boat captain, the boat driver. And so he named the moon Charon, but he really named it Charon after Charlene, his wife. And so if you hear somebody describing the moon as Charon, they don't know this story. And if you hear them call it Charon, as you now do, you know the story behind it. So it turns out that Charon is a fairly sizable satellite, as at least compared to Pluto, and they orbit in a way such that their center of gravity, what's called the barycenter, is outside of Pluto itself. Our Earth-Moon system is a similar mismatch like that, but the barycenter of the Earth-Moon system is actually still inside the Earth, but not so with Pluto and Charon. And so this is what happens as they dance around each other, and they're both locked in synchronous rotation. So it takes Charon 6.4 days to go around Pluto, and Pluto is locked facing Charon and vice versa, and that explains Pluto's apparent orbital rotation period of 6.4 days. Well, that was great, but we still didn't know anything about the surface or really the diameter of Pluto. And in 1985, a fortuitous situation happened whereby the Charon was passing in front of and behind Pluto for a couple of years. And this by carefully monitoring the combined light of the two objects, we got a little bit of a handle of their relative diameters. The upshot of all of this that I'm showing you here is that over time, when Pluto was first hypothesized, back first by Herschel and then by Lowell and Pickering, it was thought to be much more massive than the Earth, maybe 10 times more massive. And then it got discovered, it wasn't very bright, and then methane was detected. And so we got to the point by the 1980s, down here over here, where it was realized that Pluto was just, less than, was really only a couple thousandths of the mass of the Earth. It could not possibly be affecting anything, and its stature began to be called into question. Now, that changed a little bit when in 1988, James Elliott from MIT and a team from MIT took the Kuiper Airborne Observatory out over the Pacific and recorded the occultation of a star by Pluto. Pluto passed directly in front of a star, and this was the path, this was the combined light of the two objects together. So here we are, we're basically measuring the brightness of the star, which is much brighter than Pluto itself. And then suddenly the star takes a dip because it went behind Pluto and now it's out again. And if Pluto had no atmosphere, this dip would have very straight vertical lines, but you can see they're somewhat sloped. And it proved the fact that Pluto had at least a tenuous atmosphere. And this was a big, exciting discovery. I have the privilege and the honor of being on that flight. I was on the flight when Pluto's atmosphere was discovered, and it was really very, very exciting. So fast forward to the Hubble Space Telescope days, and we began to eke out little bits of detail on the surface of Pluto The color here is relatively correct. It did have this kind of orangish cast to it. And we were able to determine that there were bright and dark markings all over it. Now, the interesting thing is that this is a flip comparison of two Hubble images taken about 9 years apart. And they're projected to be the same. And I want you to notice how much the character of the bright and dark markings changes. But I want you to notice this one right here, this bright spot kind of stays the same in both. That will come into play a little bit later on. But clearly something was happening on the surface of Pluto. Ices were moving around or something, who knows what. And so Pluto maintained its, Pluto had been predicted to be discovered as the 9th planet. It was discovered at Lowell Observatory, where Lowell had made the prediction. The observatories at the time, Clyde Tombaugh's bosses, made a big sort of PR deal about it. And it was, we named the planet Pluto. Well, we didn't, but this object became called Pluto as the 9th planet of the solar system, even though it was kind of small and, not very consequential. But that all changed in 92 when Dave Jewett and Jane Liu discovered an object temporarily designated in 1992 QB1, now known as Albion, out in the general vicinity of Pluto. And it turns out that that object is one of a great many objects in what is now known and recognized as the Kuiper Belt. You can see up there at the top Pluto's orbit for comparison, which in turn is embedded in an even larger cloud known as the Oort cloud. And both of these are sort of primordial from the birth of our solar system. And in fact, the Kuiper Belt is essentially bits of matter that condense into icy bodies. After the formation of the planets, they are leftovers from planetary formation. This is a top-down view of the outer solar system. Pluto's here. This is the orbit of Neptune, Uranus, Saturn, Jupiter, and all the rest of us are close here to the sun. And all the red and white dots are objects in the Kuiper Belt. This image is more than 2 years old, and it turns out that the Minor Planet Center has not updated this graphic. They must have a manpower shortage or something there. But in any case, the red objects are what are considered the classical Kuiper Belt. These are essentially in the plane of the planetary system. And all the little white dots I want to call your attention to, these are all objects which, like Pluto, have a 3-to-2 orbital resonance with Neptune. All this by way of saying Pluto is dynamically, at least, not special, nor is it physically very special. It's a very small body. It's one of the largest objects, if not the largest object, in the Kuiper Belt, as far as we know. But it certainly was a lot smaller than all the rest of the planets. And here's a comparison. Here's the Earth and Moon compared to Pluto and Charon. Pluto's actually quite a bit smaller than our own moon. So by the late 80s, astronomers were starting to wonder aloud whether, in fact, Pluto deserved to have planetary status. And by the 1990s, this had really kind of reached a fever pitch. And it got to the point where the International Astronomical Union had to, they issued an edict saying, look, Pluto is a planet, period. Pluto is a planet, end of discussion, which made a lot of people happy. This is actually a comic by an artist named Dave Grandlin, who's out here in the Metro West. Interestingly, he didn't actually draw Pluto, he drew Goofy, but all right, never mind. So that seemed to settle it for a while. And I mentioned that Clyde had made a tour of the Boston area. He gave a presentation at Harvard where he actually met this guy on the right, who Brian Marsden, who was sort of the gatekeeper for all discoveries in the solar system at the time. And Brian was one of the principal outspoken critics of Pluto being called a planet. He wanted it to be a minor planet, just like an oversized asteroid. And so they met and they were cordial and they were pretty friendly. But I want you to notice the death grip that Clyde has here on Brian's hand. That it was definitely a photo op. Okay, so the IAU had put its mark on things and said Pluto is a planet. And then in 2005, Mike Brown and his team discovered an object out in the Kuiper Belt, which came to be called Eris, which appeared to be larger than Pluto. Now we have a problem, because if Pluto is a planet, then Eris, if it's really larger than Pluto, must be a planet. Or imagine that Pluto had never been discovered. Discovering Eris in 2005, we'd call it a Kuiper Belt object and not call it a planet. And so therefore, is Pluto a planet? This argument raged for a year and a half. This is a sort of artist concept showing the variety of the very largest objects out of the Kuiper Belt. Here's the moon down here in the corner for scale, Pluto and Charon, along with other moons that we'll mention in a minute, and other objects. Eris, it turns out to be almost exactly the same size as Pluto. It's just a tiny bit smaller, as best we know. But it still brought the whole discussion to a head. And 15 years ago now, the International Astronomical Union, which meets every 3 years, met in Prague, and they decided to decide what constituted a planet. They had a committee that tried to come up with definition for a planet, and there was a lot of back and forth. The European planetary community had a lot of dynamicists who wanted Pluto to just be a Kuiper Belt object because dynamically that's what it is. A lot of the American astronomers still felt that it deserved planethood, and they went back and forth and they debated. Is it what's a planet? Is it a and so forth. And so the recommendation came down and is actually from this task force, and it was voted down. And what they did instead, and this was the actual vote, I guess you had to have a yellow card in order to vote. They voted to approve this definition. This is the definition of a planet. It is a celestial body that is orbited around the sun. And so I guess that all the other objects that we find orbiting other stars don't count as planets. It has enough mass to be round, which is okay, that's kind of reasonable and sensible, except that when you discover a distant object, think of Pluto, for example, you have no idea what its mass is. It wasn't until we had discovered a satellite around Pluto that we could determine its mass. And then here's the catch. It's cleared its neighborhood around its orbit. And over the years, I've tried to come up with a decent analogy for this, what clearing the neighborhood means. It means it's massive enough that there's nothing else around it. It's been scattered out. You think back to your school days, grammar school days, and you're out on the playground at recess, and the school bully starts walking through the playground, and it's a he, right? And he's looking to pick a fight. Well, you get out of the way of this bully, and that's what clearing the neighborhood is all about. So the problem is that clearing the neighborhood only works when you have dense packing of bodies. And so by this definition, by the way, so this is what was going to be called a planet, and objects that weren't massive enough to meet this definition were going to be called dwarf planets. And so one of these is a dwarf planet, that's Ceres, but Vesta does not count as a dwarf planet because it doesn't have enough mass to have made itself round. Vesta is a little bit oblong. And then the question became, well, is Earth a dwarf planet? Well, no, of course Earth is a dwarf planet because it's near the sun and it's cleared out its orbit. But if you took the Earth, imagine taking the Earth and taking it out to the distance of Pluto, although Earth is pretty massive, it would not be massive enough to completely clear its neighborhood. So it wouldn't satisfy the criterion of being a planet. Okay, so all that is preamble. 15 years ago and change, we launched the New Horizons spacecraft to visit Pluto and the Kuiper Belt. I'm sorry, that's right. So it was launched in 2006. It arrived there in 2015, which is like more than 6 years ago at this point. Here's its trajectory. It passed by Jupiter at close range to pick up some speed. And here was its launch. And it left the Earth at the fastest velocity of any interplanetary probe, something like 50,000 miles an hour. It did some imaging of Jupiter during its flyby of Jupiter, sort of a test of its instruments. This is not the Great Red Spot. It's one of the other big ovals that orbit in Jupiter. It did some imaging of Io. You can see this is a little GIF animation showing an erupting volcano near the pole of Io. And so it headed out to Pluto. And by the time of the launch, we realized that Pluto had another couple of small satellites, Nix and Hydra, also taken from mythology of the underworld. But by the time after New Horizons was launched, we realized that there were two more small satellites called Kerberos and Nix. And Styx, I'm sorry, Kerberos and Styx. And so now we have a problem because these new satellites are so small that if something were to hit them, they would debris would be kicked off that would not readily get swept back up. And so there was some concern by the New Horizons project, that there would actually be a ring around Pluto that would create an impact hazard. Well, that turned out not to be the case. And so Pluto was visited by New Horizons in July of 2015, and Pluto's tipped over on its side as it orbits, and its moon system is likewise tipped, so it kind of presents a bullseye pattern in space. And so New Horizons was going through there pretty fast, and because of Pluto's very slow rotation rate, we really only got a good look at half of Pluto during the flyby. These are the experiments. For those who are of a certain age, you will identify with Ralph and Alice. And yes, they are named after the two characters in The Honeymooners. Power is supplied by an RTG radioisotope thermoelectric generator, which is a fancy way of saying that there was encapsulated plutonium, and the heat from that was from the decay of the plutonium was converted into electricity. And this is not an experiment, but on the underside of the spacecraft is a small canister that includes some of the cremains of Clyde Tombaugh. And so he did get to see, he did get to visit his namesake, Pluto. All right, so let's take a zoom in right along with New Horizons just for comparison. This is the very best Hubble Space Telescope image of Pluto, and with a year to go, this is now all New Horizons stuff. The spacecraft was already resolving Pluto and Charon, and then with 6 months to go, the detail got a little bit better. Notice that Charon is darker than Pluto; it's not as reflective. And now, with only 3 months to go, we're starting to see some surface detail. And you can see that barycentric motion. You can see Pluto wobbling here in a way around the center of mass. And now, just 3 weeks to go, we're really starting to see a lot of detail on Pluto. And this is the pair, Pluto and Charon. And you know, even from afar, there were a lot of tantalizing details, like this bright white spot, which came to be called Tombaugh Regio. This was the heart of Pluto that some of you might remember seeing. Whereas Pluto is covered with methane ice, Charon is covered with water ice. Now, because of the flyby geometry, there was an entire side of Pluto that we didn't get to see very well, and this is that poorly seen side. This is, for the rest of our lives, this is the best that we're going to see of this particular hemisphere of Pluto. There's some tantalizing details there, but not a lot we can really talk about. Really, it was the other side of Pluto that was seen well. And this is a sequence showing it going around in its rotation. And so here we are. This is on encounter day. Now, Pluto is so far away that the light travel time is something like 4 hours. And so we didn't actually have a record of Pluto being visited during its the close flyby of New Horizons. It was all recorded to tape. There was no live stream or anything like that. This was down at the Applied Physics Lab at Johns Hopkins in Maryland, which was the control center. It was not NASA, not JPL. It was at APL. And this is the formal countdown to the flyby of Pluto. And I want you to notice that the countdown begins at 9, not at 10, because Pluto is the 9th planet.
9, 8, 7, 6, 5, 4, 3, 2, 1.
People got very excited about something they could not possibly see. Well, New Horizons was fantastically successful. And this is a natural color image of Pluto. And there is that big heart, Tombaugh Regio. And it now turns out to have two kind of distinct halves. So the whole thing is Tombaugh Regio, and this half is called Sputnik Planitia, this sort of extremely white part here. And this was the part that in the Hubble telescope images stayed bright all the time. This is a natural color view. Notice that there are bright and dark markings. And then this is a false color view, which brings in some of the near infrared imaging. And this is how we're able to start telling some of the surface materials that are on the surface of Pluto. This is definitely nitrogen ice here with a skim coat of methane ice. Pluto does have this thin atmosphere. This dark reddish stuff over here might be rich in, gooey organic compounds called tholins. And we now realize that Pluto is not just an ice ball, a giant ice cube. It does have about half of its diameter is rock, and the outer half is mostly frozen water ice. And it's thought that at the base of that ice layer between the ice and the rock is perhaps a liquid water layer that is still liquid, which is remarkable if you think about it, because Pluto doesn't have much mass or surface area, and you would think that it would have chilled just completely frigid all the way through over 4.5 billion years, but apparently not. One of the interesting things about Pluto's surface is that many areas are heavily cratered, which suggests to geologists that they have been exposed to space a long time. They're old surfaces. They've picked up a lot of craters, but Sputnik Planitia and Tombaugh Regio over here are almost crater-free, which again says that these must be very youthful surfaces. So we found all kinds of things going by Pluto with the cameras, that there are sticking up quite strong topography, which unlike on the Earth, there is no rock in view. That these promontories, these mountains, are essentially exposures of rough water ice. And some of them have been named for Hillary and Norgay. This is Edmund Hillary and Norgay, I'm trying to think of his first name, who first, thank you, who first ascended Mount Everest. This is a kind of funky area showing these mountain ranges. Now I want you to notice that the mountains are kind of brightish white on top, but there's like dark stuff in between. This is kind of a talus, scientists think. And then over here, this is the edge of Sputnik Planitia, which itself is pretty weird. And turns out that Pluto, this nitrogen sea, frozen nitrogen sea, has been in motion. You can see here, there's flow marks going through here. Here's some more. You can follow the flow marks right at the edge of Sputnik Planum. And, this ice is flowing around. Something is energizing it, like a glacier flows on Earth. On Earth, it's because of gravity flowing downhill often. But in the case of Pluto, something must be, heating it and causing it to become mobile. And so these polygons in Sputnik Planum are churning around. There are all kinds of weird textures in the surface, some of which can be explained. One, like these pits, not explained very well. Here's something called snakeskin terrain right near the day-night terminator. just a weird formation. Very, very amazing stuff. And to think about it, we've gone from not knowing what Pluto looked like at all, pre-Hubble, to having details that are just less than a kilometer on the side. It's just really remarkable. And the spacecraft saw a couple of things that looked like mounds with a caldera in the center, and it was initially thought that these might be volcanoes, ice volcanoes on the surface. But recent research suggests no, they're probably not ice volcanoes, just a weird landform. But Pluto does have that thin atmosphere that was discovered by MIT back in 1988 by James Elliott and his team. It is very thin, but it is blue. It has Rayleigh scattering in it, just like Earth's atmosphere. That's telling us a lot about the particles in the atmosphere. And it turns out that it's got a lot of haze in it, and that there is a lot of individual little layers within the haze. These are not really like dust layers settling out. They're actual sort of gravitational waves that are propagating up through this atmosphere and causing condensations. I'll think of them as ripples. Well, although Pluto's atmosphere is very thin now, there's evidence on the surface that at one point it must have had a thick enough atmosphere to allow the surface temperature to be above the melting point of this nitrogen that's frozen now. But we see things that, like, there's little ponds on the surface, and there's little tiny dendritic patterns of as if liquid is flowing down hillside. And so the question becomes, how is it that Pluto in the fairly recent past was warm enough to have a thick atmosphere? And I can't go into it tonight, but it turns out that Pluto goes through orbital cycles. Remember, it's tipped over on its side, so its pole is pointing toward the sun. And it goes through orbital cycles that periodically cause these polar regions to become quite warm. And that causes a lot of the frozen material to melt and become mobile and shift around, and maybe even flow across the surface. Now, Charon is pretty weird too. I mentioned that its surface is covered with water ice. Here's some of the interesting features that we're seeing. There's a huge fracture along its midsection. And what is thought to have happened here is that, imagine that you have a water that you're freezing in your refrigerator, freezer, and the outside freezes first, right? And the inside of that ice cube is the last to freeze, but frozen water has more volume than liquid water. And so as the innermost bit of ice freezes, it can crack the exterior and cause it to expand. And that's what we think is happening here. As Charon froze throughout, it eventually sort of burst at the seams and caused these long fractures. And then there's this sort of reddish polar cap, which at first was thought to be material that maybe was imported from Pluto as a kind of deposit, but now we think probably not. In any case, it might well be related to some organic compounds. These are when you irradiate mixtures of methane, which is CH4, and nitrogen in a lab, you get higher order hydrocarbons, and they tend often to have this sort of brownish orange color. They're generically called tholins. That's a term that Carl Sagan came up with. That big gash across the center of Charon is called serendipity Cosma. And I think I have a little flyover here so that you can watch using the images that they have of Pluto and Charon from the New Horizons. This is going over serendipity Cosma, that giant, it's a rift actually, kind of like the giant rift zone in Africa, which is where two plates are tearing apart. Now, the leader of the New Horizons team, Alan Stern, had a kind of whimsical side. And so, on Pluto, there were conventions, IAU conventions for naming things, but on Charon, there weren't. And so they kind of came up with these great quirky names like Spock and Kirk, Sulu, you know, and we're Nemo, Uhura. This is great. All characters from Star Trek. Well, they didn't actually get their way with that. What was retained was Kubrick for Stanley Kubrick and Clark for Arthur C. Clarke. And so the New Horizons spacecraft also saw this 4 small satellites at some level of detail. This is the best we're going to see of them. And we also got to characterize their orbits. They have very interesting orbits. Some of them, here's Pluto and Charon here, and these have orbits that have some are very short, some are very long. Here's a little animation showing what it would look like if you could follow them in time. And some wild spinners there, and some are even spinning retrograde, which is opposite the sense that you think they would be. Okay, so we went from 1990, where Pluto had not yet been explored. You might remember that the Postal Service created a whole series of 9 stamps after Voyager 2 went by Neptune, but Pluto hadn't yet been explored, so that was its stamp in that collection. And now it's an obsolete stamp. We now know that Pluto has been explored. And in fact, Pluto did get its own stamp about 5 years ago, along with New Horizons. And so I've got some of those stashed away in the drawer somewhere. Here's Alan Stern with his famous bumper sticker, "My other vehicle explored Pluto." He's quite the character, Alan is. Now, the interesting thing, I think, I've been in this game a long time. I remember, and some of you probably remember, the Mariner 4 flyby of Mars, which is July 14th, 1965. That was our first close-up look at another planet other than the moon. And exactly 50 years later, to the day, New Horizons flew by Pluto. I think that's a remarkable coincidence. Well, that was not the end of Pluto's of New Horizons journey. It was billed as an exploration of the Kuiper Belt. And so after it left Pluto, the goal was to try to find another Kuiper Belt object to visit. And they did identify one, barely, just in time, which got the nickname of Ultima Thule. These are the discovery images. They had to use the Hubble Space Telescope to find something that New Horizons could fly by. And the predicted flyby date was January 1st, 2019, so not quite 3 years ago. And I'm going to kind of skip by this. It turns out that amateur astronomers using off-the-shelf Dobsonians recorded an occultation, actually a couple of them, by this object, MU69, and were able to, we needed to know exactly where it was in space so that New Horizons could be maneuvered to fly past it. There was a series of 3 occultations in a quick succession during 2017 and 2018. One of them involved tracking with the SOFIA, this is NASA's flying observatory. That big hole in the side of the 747 contains a very short focused, large reflecting telescope that looks out the side. And it was this occultation here in July of 2017 that really nailed it. And you can see, if you watch really carefully, that little blink there, that is MU69 passing in front of that star for just a fraction of a second. It was recorded by a couple of stations, and the upshot was that it wasn't round. It probably was shaped like a peanut based on this fit to the occultation tracks. So here we are 2 years ahead of the flyby, imagining what this place is going to look like, and here is January 1st, 2019. I was down there for this encounter. It was a great way to spend New Year's Eve and New Year's Day. And so a lot of kids, these were kids that I think they were all born since New Horizons was launched, and I think they're members of the children of the team members. So this is what this object looks like. MU69 was its sort of temporary designation. It is what's called a contact binary. These are 2 objects that were at one point in orbit around one another, and they they sort of spiraled in on each other until they connected at this neck, which is bright. It's a period, some interesting bright material. This is a little series of images showing out in that portion of the Kuiper Belt how we think these objects came together. They formed as a sort of binary like this, and then they eventually got stuck together and became a single object. And that Akasa Lineae is the join, and you wonder why it's bright. It's probably a localized concentration of ice. When we imagine this thing out in the Kuiper Belt and things are peppering its surface all the time, vaporizing little bits of ice as gas. The gas doesn't completely go away. It heads toward the center of gravity, which turns out to be right along here, and it condenses and it forms a little ice ring. And so this object really represents. It's now been formally named Arakoth, which is a word meaning sky from the Powhatan Native American tribe, which is the tribe that inhabits the area of Maryland, all the mid-Atlantic actually, but the area of Maryland in which the Applied Physics Laboratory exists. So it's an indigenous name, Arakoth. And so that's where we're at. New Horizons is on its way into the greater depths of the solar system. It's now 50 astronomical units from the sun. And for those who were asleep for the first 58 minutes of this talk, I will tell you everything that you need to know about Pluto in 80 seconds.
Pluto explored. How are Earth and Pluto alike and different? Pluto is very far from Earth, 3 billion miles, and very cold, minus 380 degrees. Earth is almost 6 times larger, but the two planets are alike in many other
Oops, what'd I do?
other ways. Both have glaciers made of ice. Here on Earth, that's water ice, H2O. On Pluto, it's frozen nitrogen gas, which still can glow, even at such low temperatures. On Earth, our mountains are made of rock. But Pluto's so cold that water is as hard as rock and holds up mountains as tall as the Rockies. We've got volcanoes here on Earth that erupt red-hot lava. And it sure looks as if there are volcanoes on Pluto, but most likely oozing exotic ices such as carbon monoxide and methane. Both planets have blue skies and atmospheres containing nitrogen. And both have oceans, with Earth, of course, outside. But Pluto's likely deep down inside. Earth and Pluto, very much alike and totally different. That's Earth and Pluto explored.
Okay. So
Pluto.
I think that's it. So I'll stop sharing. Or I think I'll stop sharing. Sharing has, okay, all right. So thank you for your attention, and I'd love to entertain some questions if you have them.
Thank you. Real quick, do we have any questions from the people on Zoom?
I'd like to know about X-rays that they have detected coming from Pluto.
Yeah, so well, first of all, Eleanor, I will say that I'm not familiar with that. I can imagine that X-rays can be coming from the interaction of X-rays with the gas in its atmosphere. We know that a lot of comets actually have give off X-rays because cosmic ray particles and others, very high energy particles, interact with the gases around the cometary nucleus. So I will have to look that one up. I confess I do not know about that.
Anybody else online with a question? Bill, nothing from you?
Well, the status of Plutoids. The IAU mentioned Plutoids in their definitions, and I'm wondering whether that is now being an accepted verbiage.
No, no one uses that. I think that you know there is a dynamical definition called Plutino, and Plutino is one of those Kuiper belt objects in a 2 to 3 resonance with Neptune as Pluto is. But in terms of Plutoids, you know, things like Eris and Albion, objects that are close in size, you saw that no one is calling them that. There is this more broad characteristic of dwarf planethood. And so, interestingly, the IAU group that's responsible for making that call, whether something is or isn't a dwarf planet, basically has abrogated its responsibility and is not doing a good job of that. It's up to the rest of us to decide which are the dwarf planets and which are not.
I would think a Plutino would be a massless planet. Very difficult to detect.
Exactly. Instead of coming from the sun, it's coming from the outside in, right?
Right. Looking online right now in the chat. It looks like your green screen. So, and we're not going to allow any more puns. Sorry, Fritz. Okay, do we have any questions from the room here? Just speak normally, the microphone's on the ceiling.
And Eleanor, while we're waiting for that, I quickly looked it up. It is, in fact, that was a result announced in 2016. And they do believe it's the interaction of the solar wind or high energy rays with the atmosphere of Pluto.
Thank you. That's great.
Well, I have a real quick one, Kelly. Is Pluto still the largest Kuiper belt object we know of?
Yes, barely. You know, the hunt is on for this mythical Planet 9 or Planet X. And that is because some of the Kuiper belt objects with the most distant orbits that go hundreds of astronomical units from the sun are highly elliptical, and they appear to be aligned in a way that suggests some massive body has reoriented and organized their orbital planes. We haven't found the object yet, but there have been now going on 10 years has been the notion that there is this very massive object out there that has yet to be discovered. And the hunt goes on. The two big teams that are looking for it are Michael Brown at Caltech and Scott Shepard at Carnegie. And so, you know, there may be objects in the Kuiper belt that are bigger than Pluto, but they have to be, and you know, a lot of people are looking for Kuiper belt objects now. And so it would have to be sufficiently far away that even though it's large, it's too dim to have been picked up.
Okay, thanks. Looks like half of GAAC is online. Jim, do you have a question, or Phil? Anything before we move to the room? No? Anybody have any questions here?
A quick one. What's the minimum size of telescope do you need to see Pluto?
Right. So a really great question. Pluto, as I mentioned, was closest to the sun in 1989. And it has a fairly eccentric orbit. So it is moving farther away from the sun progressively. Even when it is closest to the sun, or when we're closest to Pluto at opposition, it's getting dimmer and dimmer. There was a time when you could pick it up pretty well with an 8-inch telescope. Now I would think that 10 inches of aperture would be marginal, more if you've got it. Or, you know, Mario would probably pick it up and discard it because it was probably in the way of some nebula he was trying to. Tell him I said that. So yeah, a 10-inch telescope, I think. I have all the trees around my property. I live in Chelmsford, so it's pretty dark here. And so I have a 9.25, and I haven't actually tried, but I might someday. By the way, and I have a question for you. I know that there was a lot of mobilization of dark sky advocacy around the Halibut Point observing area. Can you give me an update on that?
Problem solved.
Good.
We had to get a special use permit from them, and to get the permit, we had to have $1 million liability policy. But that's small change for GAAC, you know, we're rolling in it here.
And the DCR put in lights that are both reasonable and can be shut off, I think, right?
They haven't done anything with the lights. We're deep inside the park now, up by the visitor center where it's very, very dark.
Okay, great.
There's a rogue street light that was lighting up our whole observing field, so we weren't all that sorry to see it go.
Yeah. And so for Bill Waller, who put that link in the chat to Plutoids, that's dated from 2008, right? Which was just shortly after the IAU vote. And I keep pretty close tabs on the literature. No one is using that term.
So where does the hydrocarbons on Pluto come from?
Ah, great question. So you have methane, CH4, and you have nitrogen, which is N2, or that's molecular nitrogen. And you might remember the slide I showed with those little vials of brownish stuff. If you take methane, nitrogen mixtures and you irradiate them, you get higher order forms of hydrocarbons, like formaldehyde, for example, has the formula HCN. And so if you can imagine like really complex hydrocarbon chains, tar-like substances, you don't need oxygen. Those three are sufficient to get you, fairly high mass organic matter that compounds that tend to have that color. Just by taking the ices that are there, the nitrogen ice and the methane ice, and irradiating them with cosmic rays and ultraviolet and all that over a long enough time, those reactions take place.
Thank you.
Oh, somebody is pointing out that HCN is cyanide. Yes, thank you very much. I think it's well, anyway, I'll take the cyanide. Thank you, Tom. You've been very careful with me. But I know that formaldehyde is it C2?
CH2O.
Is formaldehyde? Thank you.
H2O is formaldehyde.
Thank you very much. I stand corrected. I have the HCN right. I just didn't have the name right.
All right, well, thank you, Kelly.
All right, it's been a
Another
great
round of applause for Kelly.
understanding. I really always appreciate getting together with you, and I hope we get another chance soon. I should mention that in a week I leave for Antarctica to hopefully see the total eclipse of the sun on December 4th. And I don't think the odds are with me. There's about a 10% chance that we'll have clear skies that day. But we'll get to, my wife will be able to claim her 7th continent, and that's happy wife, happy life, right?
Kelly, will you be needing another GAAC sweatshirt for the trip?
No, thank you. I think if you instead of the sweatshirts, if you started a line of thermal underwear, you might get some.
But where would I write GAAC on thermal underwear?
On the seat. Where the 2 buttons are that you drop down the.
Oh yeah.
You have to change it to GAAC.
Yeah.
We could put it on the inside of the flap.
Exactly.
That's
Southern exposure.
All right,
Anyway.
thank you, everybody.
Yeah, thank you all.
Good job here.
really enjoyed it. Thank you very much.
Hey, listen, for our holiday party, Kelly, I hope you can make it. We've got Rachel Tillman, who is taking over for Pat, whatever her name is, that was one of the scientists on the Viking.
Oh, yes.
And she died 2 months before she could speak to us.
Oh, wow. That's
A couple
awesome.
of years, last year or the year before. So Rachel Tillman is going to be our speaker, and she's taken over all of the science, preservation and library and all that. So that should be a pretty good one. If I'll send you an invite.
That'd be terrific. Thank you. Thank you very
All
much.
right, closing up shop, folks. Thanks for coming.
All right.
Thank you,
Thank you.
Michael.
Bye-bye.
Bye.
Thank you.
Thank you.